So what do we calculate for the z-score?
I got
I have a vote for negative 0.83.
I got the same as Walker. 0.5.
Alright, go ahead and try part B. Try part B.
Oh. Oh.
I got 1.3, 1.315. I got 1. Where are you going? Looks like I'm getting you guys.
Is that negative 0.8?
Yep.
That's the correct answer. T minus 11.
What do we get for part B?
I got 1.2.
Now, let's take a look at these two results and look at some analysis that we can do with this. So obviously, yes, we answered the question for finding the z-score, but why moreover we care about the z-score? What does this tell us? Okay, so first of all, I learned initially that obviously A's hourly amount was less than the mean, whereas B's was greater than the mean because A is negative, B is positive. Next thing that I noticed, of course, is that we have two different values here for the z-score. So they're both not the same distance from the mean. Is this better here? Oh, okay. Now, what I noticed, of course, is that in these different numbers, that means that they are not, of course, the same distance from the mean. This guy is 0.83 from the mean, so not quite a standard deviation away. This guy here, over a standard deviation away. So, of these two, which one is further from the mean?
I would say B.
I would have a vote for B. Of these two, which one is further away from the mean?
Well, what are you doing?
A.
I forgot what the name was.
So, let me ask this question. If we had an x of 1158,
Hey.
You wait, bro.
I understand we still have one more day till Thanksgiving, which means that we have a full class here that we need to discuss. We need to stop. This is getting ridiculous. I'm going to stop. So, our question that we asked originally was which one is further from the mean? We had a vote for B, and we had a couple people who voted for A, and we're not getting very good results with the amount of people who are voting. So I asked additional questions. What would happen if our x was equal to 1158? What would our z-score be in that case?
Yeah, according to the Z-score, just standard deviation above the mean.
If our X was 1158, what would be its Z-score? 0.
0.
So the mean in any of these situations is at 0. So again, I ask, if the mean is 0, which one of these two is further from the mean?
So what is B?
Maybe B, yeah.
It would be B. Because 1.27 is further away from 0 than 0.83. Yes, there is a difference of negative and positive, but that just means the direction you're going. Okay? Questions?
Okay, negative and positive.
Yes,
So
ma'am.
we go based on how far it is from 0?
Correct. So you're basically looking at the absolute value. Folks, if you have a question, raise your hand. Otherwise, I should not hear you. Yes,
You
sir.
said 0 gonna be next time?
Correct. Any other questions? All right, so we're going to try a little on our own. So please turn to page 170. We're going to take a look at number 5. I don't understand how that garners so much conversation. Take your textbook out. Read 1 second.
I can't.
You tried it.
Thomas.
Is there any other additional information we can send Hey guys.
Put a roster up.
Those textbooks that aren't getting open. Now, what we just did in that example had one set of data we were comparing for 2 different individuals. One mean, one standard deviation. We looked at 2 separate individuals and compared their mean scores. That is not always the way that those problems are presented. In some cases, rather than just compare within one set of data, they look at 2 different sets of data and compare between those 2 sets. So, if you look here at this particular problem, they start out telling us that we're talking about the year 2010 and all the babies that were born. So, knowing that, is this a sample or a population? This is a population. We're talking about all of the data for all of the children that were born in 2010. Now, they tell us here that we're starting off talking about one's babies that just dated for 32 to 35 weeks. So that is the category here that they're talking about. Those that lasted 32 to 35 weeks had a mean weight of 2,006 grams.
Why are they doing it in grams? They did not have last time.
And then we have a standard deviation of 660 grams.
So, how many grams are in a pound again?
No idea.
I have a question. Where's the conversation about grams instead of pounds?
There are 1,000 grams in kilograms. Kilograms are comparable to pounds, but they are not the same.
What is the limit?
Folks, we're going to focus on this problem now. That is not what we for tonight. Now, it also says in the same year, we're looking at babies that just dated for 40 weeks. So a separate set of information. They had a mean weight of 3,500 grams and a standard deviation of 470 grams. So, in these first 2 sentences, we learned that we're dealing with 2 separate pieces of information. So, at this point, I would make myself 2 columns and label them with this information so I can keep myself organized. So we started off with the 32 to 35 week. They gave us the mean of that situation and also the standard deviation. And then we have 40 weeks. And they gave us the new mean and the new standard deviation for those.
That'll be the mean.
Now, of course, we haven't gotten to the point where they gave us any X's yet. We haven't gotten to the point where they asked us questions. We have the information they gave us in organized fashion, so that way we can find those other pieces and be able to have
Oh, excuse me.
So I continue reading. It says, suppose we have a 34-week baby. So that, of course, falls in the 32 to 35. And this baby weighs 2,400 grams. But they also tell me that I have a 40-week baby who weighs 3,300 grams. What do those two numbers represent in their separate situations?
Well, that's, what do you got to look at?
No. The real question is, what does this represent to the z-score formula?
The X and the
The x. So we have an x for our 32 to 35. We also have an x for our 40. And so we notice, of course, they have three questions for us. Because first of all, what is the z-score for the 34-week baby? What is the z-score for the 40-week baby? So we can calculate those two separate z-scores. And then they asked us which one, of course, weighs less relative to the mean. So once we get those two z-scores, we can make that determination. So at this point, we just need to substitute into our formula.
Oh,
And then, of course, do our calculation.
Mister, I don't have a blue purple. Sorry. I don't have a
Booklet, remembering. Now, please notice that if you want, obviously, when you calculate a z-score, you subtract and you divide. I would do those in two separate steps. Or, so if you want, calculator does have another function to it that's actually, I think, kind of helpful. If you press Control and then divide, we'll actually set up a little fraction for you. So that you can just type the information in where you need to, so you don't have to do two separate parts. Again, that's completely up to you. That is the way I like to handle it. Questions about our z-score? Now, they did ask us that third additional question, which was which baby weighed less relative to its gestation period. So looking at these two z-scores, which of the children weighed less?
Oh, yeah, because No.
You said 30.
The Z, because it falls off 0, right? So it's the second one. Is that what we're looking for?
Now, the first thing that I would look at is the sign. One is negative, one is positive, and it's very clear which one was less. But they're both negative. So which one of those is going to be less relative to their mean?
Oh, wait, no. That's the smallest number right there.
Which one?
That one.
Which one? Or that's the smallest one? Right. So remember, of course, in negative land, that even though these are bigger numbers, this means it is less than this guy over here. So our 40-week baby actually weighed less relative to its gestation period than the 32 to 35 baby. Let's just all right, go ahead and try number 6. Okay, folks, we're working on number 6.
You got it. Oh, so we're on number 6. No, we just did it. Well, we did 5.
Folks, we're working on number 6.
Wait, number 6.
Oh, no.
What the similarities between them?
What's that on there?
We will get song called Ready. I think it's Ready.
You looking hard for a
She was a hit though, like running. Are you okay? I was hearing something. You were, that's right.
She's so dramatic.
Really, what are you talking about?
RZ scores for number 6.
That's how I read. What's the effort to what I do?
Now, the third question that they asked, once again, was which of these babies is less relative to their gestation period.
32, 35.
Okay, so of course, 0.61 is less than 0.85. So our younger baby here would be less relative to the gestation period. Question. All right, so we'll head back to the note portion of our message. Next measure of position that we like to discuss is called percentile. Now, as you look at this word, percentile, what does that have to do with? Percent in some way, shape, or form. Now, I suspect that, I suspect that you probably never calculated or worked with in any numeric way a percentile, but you may have heard of these before. In particular, if you get back a PSAT or SAT score sheet, ACT, something like that, they will tell you the percentile that you scored in on the test. And so what that means is that it's describing the percent numbers that are below a particular data point in the set. Correct. And so like we said, we're focusing on one particular number, how that compares to the overall set of data. And so if you scored, let's say, in the 40th percentile, that means that your score, whatever that was better than 40% of the people. If you scored the 80th percentile, that means that your score was better than 80% of the people. So it tells you what was below. Now that also does divide the data. So if you scored at the 80th percentile, yes, 80% of the people had a score that was less than yours. But that also means that 20% of the people had a score that was more than yours. So it divides the data based on application. Yes, Chris?
What about like the GPA on, let's say like after the 25th percentile, then it'll go to the 75th. It's not like,
Right, so it's telling you that if you have a GPA that's the 25th percentile, you have a GPA that's higher than 25% of the people, it means that 75% of the people have a GPA that is larger than yours.
so 75, that's better.
Right. So with scores, things like that, GPAs, if you have something that's higher, that's better because you did better than more people. Now, it also depends on the type of thing you're looking at. For instance, if you were looking at golf scores, would it be better to have an 80th percentile score or a 20th percentile score? Because you're trying to get a lower score in golf. Okay? So you can't necessarily say that a higher number is better. It just depends on what the scenario is. Right? But like I said, it does divide the data. So P would represent your peak percentile. P. So your 25th, your 72nd, your 83rd, whatever. And so if you know the percentile, that of course tells you what's below. 1 minus that tells you what's above. So if you scored at the 60th percentile, you did better than 60% of the people, but 40% of the people did better than you. Now here's the thing. It's not particularly complicated to calculate a percentile or to find the percentile of a given number, but it is a little wonky, okay? And quite frankly, a bit of a pain because you have to have a set of data that's in order and also labeled with what number it is in the data set. So we are not going to do any calculations with percentiles, but it is important that you understand what it is and what it means. Okay? Can we stop talking, please? Questions about percentiles? Now, what is related to percentiles that we will deal a lot with are quartiles. And I suspect you might have heard quartiles before in your life. Of course, looking at that word, it has the aisles with it, so it does relate to percentiles. And what type of percentile might I be giving you? Quartiles. The quarters. Okay? So, the purpose of a quartile is to show where your data is divided into fourths. So essentially, when you're finding quartiles, you're finding the 25th, the 50th, and the 75th percentile of your data.
Is there anything lower than that? Like, is there lower or what? Oh, is it like 10?
No, you would just have quartiles and percentiles after that.
So percentiles go about what?
Correct. Now, quartiles, as we mentioned, are something that you've probably done before. To review how you find those, first thing you need to, of course, make sure that your data is in order. That's probably the biggest place where people make mistakes. It's like, oh, I know how to find quartiles. They jump right into the problem. And they don't pay attention to whether their data was actually put in order or not. So that is important. Next step is to find the median. Where is the median? No. So essentially, once you found the median, you cut your data in half. And that gives you 50th, correct. Just like if you're cutting a cake or pizza, you cut it in half one way, that gives you 50% each. And then you cut it in half the other way, that gives you 4 different quarters. So once you have your median, you now have 2 separate halves of the data, and you find the median of the smaller half of the data, that will give you Q1. And then if you find the median of the larger half of the data, that will give you Q3. Now, when you're finding any of the quartiles, the process that we discussed for median applies. So if you have a number that is specifically the center of the data, that number is your quartile, whether it's median, Q1, Q3. If it falls between 2 numbers, then again, you'd add up those 2 numbers and divide by 2 to find the number that represents that particular quartile. Questions? All right, so let's look at an example. It tells us here in the paragraph we have 25 different numbers. These represent the tuition costs in thousands of dollars. So these numbers are not 12, 14, 15, they're 12,000, 14,000, 15,000, etc. So they would like us to find the quartiles. What do we need to do first?
Find the minimum and the maximum.
The middle.
You have do something before that.
To make sure it's arranged, right?
Right, so is this data arranged in order?
No, it is.
It is. All right, so we don't have to do that part. Great. So next step, find the middle. Now you can do that, of course, by counting in towards the center. Or, since I know that there are 25 numbers, that means there is going to be a number at the center, which is going to have to be at number 13. Because 25, half of 25 is, of course, 12 and a half. So it appears that our center happens there at 23.
Which column is about?
Questions about finding the median? Now, keep in mind, since we have chosen one number out of the set of data that is the median, this number is now sequestered. Okay? When we go to find the first quartile, we're going to look at numbers between 12 and 22. Okay, 23 is no longer part of the discussion. Now, of course, I know that because there are 25 numbers in my set of data, pulled one out. That means that there's 12 to the left, 12 to the right. So my middle of that first half would be between 6 and 7. So it's halfway between 17 and 17.
17.
And of course, if we weren't sure, just add up those two numbers and divide by 2. And then, of course, we can do the same thing on the upper half of the data. And what is our Q3? Questions about finding the quartile? Alright, so let's see if we can try one with a different set of data. So turn to page 172. So you look at number 21 on page 172. Now, while we actually want to do A and B, we're going to focus on B first. What does B ask us to do? Find the quartile. So, first thing, of course, we need to do is what?
Determine if they're in order.
Okay, are they in order?
They are. Yes, they are in order.
Okay, so they are in order. Go down the columns. So go ahead and see if you can find your Q1, Q2, and Q3.
All right.
We have to write down all the numbers that we don't know.
Don't write any book.
That's okay. Yeah.
There's some water missing out of
I think that's an option that you're committed to have.
there's some water. I ain't thinking like that wasn't I can't leave it off.
That was kind of the plan. I'll give you this one for free.
Are you sure? Am I gonna get punished for this?
A lot. Oh my goodness.
Everybody's on the stage. Target? Still over. Oh, official. Bro, you wasn't on mixtape? Got you, bro. It's on done for me. I got cardio up there. I got big. Nah, I'm playing cardio. I got Lil Wayne up there too. Oh, Lil B too. Yeah.
Oh, you got a big job here?
That's it, bro.
I think you need to get some sleep.
No, all I want is for you to
That's the one to go to board?
The only one I like is
I'm asking Christine.
I'm asking you.
like, I feel like
I know what you're talking about.
you gonna get an
You play them.
Back after break, we have the second day of notice event. You can really Monday to following. Alright, so, whenever I took a look at the data, my median fell between 38.3 and 38.4, so that gives me a median of 38.35. Now, because of course we didn't circle a number there, that means that now the data is just split in half. So Q1 fell between 36.3 and 37.4, gave us a first quartile 36.85, and then Q3 fell between 40.6 and 41.4. final answer would be 41.
Yes, ma'am.
Questions about?
I got 41.
Which one?
Quartile 3.
Mm-hmm. Did you find it between 40.6 and 41.4?
Yeah, 41.4 and 41.1.
No, it's between 40.6 and 41.4. Other question?
No, ma'am.
All right, so now the other question that it asked us to look at was A. What is A asking us to do?
He is asking us, yep.
Do what? Out of these scores, right? So, did they give us a number in the question?
Yeah, 36.3 miles per gallon.
Okay. 36.3, you said?
Yes.
Thank you. Yep.
Do we have a mean?
Oh, yeah. Me, no, not yet.
Do we have a standard deviation? No. So what this would mean is that there are situations where we have problems given the sets of data, but they don't actually give us the mean and the standard deviation. We need to determine those first with the set of data before we can actually calculate the z-score. Now, initially that doesn't sound like a hard thing to do. We'll just find the mean and the standard deviation. But how does one find the standard deviation?
By telling the space between.
What is the process that we use to find the standard deviation?
Oh.
Right, we got to set up that chart. Now, that doesn't sound too bad until you realize we have 24 numbers here. And that's going to be an awful big chart. Okay? So, what I would like us to do is to take the opportunity to look at the options that are available on our calculator to assist us with this process. We do not have to go through this whole thing by hand with 24 different numbers to find the mean, do all the subtractions, do all the squaring, add them all up in the whole business. So, let me just reiterate the fact that we're going to learn something that's going to make the work a little less, and it's going to be something that we're going to use all year. So make sure you focus on this process and understand it so that you can be successful. Please stop talking. If we press the home button there, we of course have spent most of our time on the calculator page, the very first one. But as Mike said, we have to make a table in order to calculate a standard deviation. Please stop talking. And you'll notice along the bottom, we do have something that looks like a table over here towards the center. It's called a list and spreadsheet. So go ahead and select the list and spreadsheet. And it takes you to a page that basically looks like an Excel document with all of those different columns and rows and stuff. First thing that we need to do, or have the calculator help us out with this process, is we need to give our data a title. What place where you put the title is up in the A box. So scroll up to the A box and give the data some sort of title. It needs to be at least 2 letters. It does need to start with a letter, though it can include numbers after that. It needs to have at least 2 letters.
Okay.
And once you've given it the name, of course, move down and press Enter. And you'll notice it takes you into that row that I believe on your calculator has a diamond there. Up here it has an equal.
Do you have to put smart?
No, call whatever you want. Yeah.
Everybody make the KB pop, alright?
How long will it take you to stop that? And your sofa. Now, as I was saying, you'll notice that you end up in the diamond row on your calculator. Under no circumstances should you type in that row. Okay? Do not type in that row. So once you have your name, just move down to the 1. And then what we need to do is to get the data that is in this list into the calculator. Now, that doesn't sound incredibly fun. We have 24 numbers that we need to type in. But I promise you that the work that it will save you in calculating the mean and the standard deviation will be worth it. Okay? So you want to type those 24 numbers in the first column. So don't divide it up like it is there in your textbook into the 6 different columns. Just type them all straight down. It does not matter what order you type them in. You just need all 24 numbers in that first column underneath the name. Either way. Sorry. Guys, should be typing them. Thomas, where is your calculator? Go get a calculator. She needs to get a calculator.
Pay attention to my
Let me see. Because you don't know how to play.
That's better. It won't let me put the numbers in the calculator.
Please keep our names to ourselves. Now, if you believe you are done, what I do at this point is I always take a look at my data, make sure that the data that I have in the calculator is the correct number of items. So I know because I have 6 columns of 4 that have 24 numbers in this list. I look at my list that I've typed to the calculator. It ends on number 24. It should have all my numbers. Sometimes as well, I'll go scroll up through the numbers just to make sure I didn't type anything funky. I got like 2 on one line or something like that, or extra numbers in there.
You don't put them out. And you don't
Give me another 30 seconds, finish typing.
Yeah.
I did it.
Alright, so now that we have all of our numbers in the calculator, we are going to go through a process that will give us some information that's going to be very helpful here. So the first place that we need to go is to the menu. And our goal, of course, is that we are attempting to calculate some statistics for this set of data. So we will go to statistics, as well as stat calculations. Menu.
Okay, now, and I ain't there too. I had that alright.
Not the menu.
Do I have that on statistics? Data or statistics? No, I just don't. What? It's not working.
Are we all at this screen?
It's not working. Oh, alright.
Where am I going? Once you get into stat calculations, you can see that there's an extensive list of the statistics that are available. The one that we want for this purpose is the one variable statistic. So we choose that. And the first thing that pops up is a dialog box that asks how many lists do you have? How many lists do we have? So we go ahead and press enter. Now at this point, we have this very large screen of stuff. There's only one thing we need to worry about on this screen, and that is telling the calculator what set of data we need it to find these statistics of. Okay? And so, what you need to do, highlighted there on that first box, you want to press the center key of your little keypad up here, and it will list for you all of the different names of sets of data that are in the calculator. You want to pick the one, of course, that belongs to the data you just typed in. Once you highlight it, press enter. Now, just as a note for the future, if you have a situation where you have several different things in that list, okay, it can get very long. I would recommend that when you begin any class, you start a new document at the very beginning of class, so that you don't have those extensive lists of things to go scroll through. Once you have told it the name of your list, all you need to do is press enter. Now, when you press enter, you may look and say, it doesn't really look like a whole lot happening. Okay? But you'll notice over in that one row, there is something else typed. And the problem is that we are at the bottom of our list. When you start to scroll up, you'll see some stuff.
Oh, Lord.
And so the first thing that you'll notice is that here are mean, median, mode that we looked at earlier. If you scroll all the way to the top, you should locate the mean.
See it right here. Whoa, our means is not. What is your?
Now, take a look. I noticed right away, if I just take a glance over at my data, in box 2, I got something weird typed.
Yes.
So clearly I need to fix that. It should be 34.3. And when I do that, it automatically updates.
Alright. Yeah.
Now, a couple things to look at here. Obviously, our goal is that we were attempting to find the mean standard deviation for Z-score. Okay? First thing I noticed is that it does give me the mean there, labeled as X bar. Do you see anything labeled as mu?
Not necessarily, but if you look at glass, you can have something.
Your calculator, of course, does not know whether you are dealing with a population or a sample. Okay? In this particular case, what are we dealing with? Sample. Okay? And so this, of course, mean would be appropriate for that. But here's the thing. Your calculator doesn't know. So it is always going to report the mean as x bar. If you are dealing with a population, though, you need to know, hey, when I write this down, I'm going to need to write the appropriate symbol for a population mean, not the x bar here from the calculator. Okay? Because is there a difference in the way you calculate the mean for a sample or population? Right, so add them all divided by how many there are. So there's no difference in the calculation, just the symbol is going to be different. And so the calculator is always going to give you that x bar. Now the other thing that we needed was the standard deviation. Is there a difference in the way you calculate a sample standard deviation versus a population standard deviation? Yes, because one has the n, the other one has the n minus 1. And so you'll notice, you scroll down here, we have both an S and a sigma. So for every set of data that you type in, it's going to give you a sample standard deviation and a population standard deviation. It's your job to know when you're looking at a sample or population so you know which one to use. So in this case, which one do we need? We need a sample because we're looking at this information on miles per gallon. So we're going to use, of course, the S, not the sigma, for our standard deviation. So our S is 34.42 or 3.42. Our mean 38.78. Oh, you don't have to write it.
I feel about you. I'm so serious. Oh.
Do we now have all the information we need to calculate these scores?
Yeah. Real long. I didn't know.
You may remember a few classes ago we had a discussion about the fact that I was on the fence as to which way this class was going to go. Today has made the decision for me. And so I apologize in advance for that which will happen when we return. At this point, I do need to see your notes of classwork. Card?
I'm never quit training. That's why I'm quit training right now. All the work, everybody.